the arithmetic average of the absolute values of the deviations from an average, that is mean or median or mode, is called mean deviation. Now, the mean deviation is nothing but the arithmetic average of the absolute values of the deviations from an average. Average is nothing but either mean or median or mode. This is called mean deviation. This is the definition of mean deviation. We can say that this is the definition of mean deviation. Now, how to find the mean deviation? Mean deviation can be found for ungrouped data. So, we are finding mean deviation of ungrouped data. Mean deviation of ungrouped data. And ungrouped data means they will give the values, variates are given to you. Using the variates, we should find out the mean, arithmetic mean or the median or mode, whichever is required. Let x1, comma x2, comma x3, so on xn be n variates or n values, we can say, and A be the average, and average is nothing but mean or median or mode. A be the average, that is mean or median or mode. So, x1 minus A, comma x2 minus A, comma x3 minus A, xn minus A are the differences. And modulus of x1 minus A, comma modulus of x2 minus A, comma modulus of x3 minus A, so on modulus of xn minus A are absolute values. Absolute values are the differences. Now, if you add all these absolute values and if you divide with number of quantities, you can get the mean deviation. Mean deviation is given by the formula modulus of x1 minus A plus modulus of x2 minus A plus so on up to modulus of xn minus A divided by n. Or in terms of sigma, we can write this as 1 by n into sigma I runs from 1 to n modulus of xi minus A. If x bar is the mean, then mean deviation from mean is given by sigma I runs from 1 to n, here 1 by n into sigma I runs from 1 to n modulus of xi minus x bar, where xi can be calculated using the formula sigma I runs from 1 to n xi divided by n. So this is the mean deviation. This x bar is the mean. Then mean deviation from the mean is given by this formula. Here x bar is given by the arithmetic mean. That arithmetic mean can be calculated by using the formula sigma I runs from 1 to m xi divided by n. If m is the median of the data, if m is the median of the data, then mean deviation, m is the median of the data, then mean deviation about the median, mean deviation about median is given by 1 by n into sigma I runs from 1 to n modulus of xi minus m. Here m can be calculated by writing the given variates in ascending order. In ascending order, if number of variates n is even, we can get the median as the average of n by 2 comma n by 2 plus 1 observation. And if n is odd, then n plus 1 by 2th observation is median. If n is odd, then n plus 1 by 2th observation is median of that data. So we see this. This can be, if m is the median of the data, then the mean deviation is given by the formula 1 by n into sigma I runs from 1 to n modulus of xi minus m. And this m can be calculated by writing the given variates in ascending order. If the number of variates n is even, we can get the median as the average of n by 2th and n plus 1 by 2th observations. If n is odd, then n plus 1 by 2th observation is the median of that particular data. This median can be used there to find out the mean deviation.